This is pretty awesome because normally I do this kind of stuff online, and getting to see your faces is, it's a new experience for me. So in case all of a sudden I'm staring like a deer in the headlights, you know why. Now, we've got an awesome panel, and I'm very excited to talk with these legends that are on stage with us. You can see the wonderful panelists that we've got. I'm going to ask them to give a quick run-through of who they are because they have long list of credits behind their names, and I couldn't remember all of it. So I'm going to go ahead and ask Ines to start us off and let us know who you are and what you're doing, and then we'll get into this panel. And we will leave 10 minutes at the end of the panel in case anyone has questions. So, you know, think of questions. All right, there we go. Ines, kick us off.
Hey everyone, I'm Ines. I'm a co-founder at NumberStation, which is a startup that does data transformation, data preparation with foundation model technology. And before NumberStation, I was doing a PhD at Stanford in AI, and specifically in using AI to automate some data work like knowledge graph construction. Towards the end of my PhD, we realized that foundation models basically could replace all that work that we've done. But that was also exciting, and that's why we decided to start NumberStation, and super excited to be here today.
Great. So I'm going to zigzag through. Jonathan, can you give us who you are? And I think your life's changed a little bit in the last couple days.
So I'm Jonathan Frankle. I'm chief scientist at a startup called Mosaic ML that will no longer be a startup in another couple weeks. I'll be chief neural network scientist at Databricks shortly, which is very exciting. I train neural networks, and my focus is on doing so as efficiently as possible. I spent my PhD at MIT studying that, and now at Mosaic, and soon to be, I guess, at Databricks, we're going to drive down the cost so everybody can train a foundation model for themselves.
There you go. All right, Emmanuel. Yeah. Go ahead. Yeah, let's give it up for him. And huge congrats on the acquisition. That's awesome. Emmanuel.
Yeah, hard to top that in terms of a big day, so I'm impressed you're still alive. I'm Emmanuel, Ameisen. So I worked in machine learning for a while. Most recently, I was at Stripe, where I led some ML efforts on the fraud team, and I'm now part of the technical staff at Anthropic, where we work, on building.
Excellent. And Andrew, can you give us who you are?
Sure. I'm Andrew Dai. I'm a principal software engineer at Google Deepmind. And I've been working on language models since around 2015, when we were building small models with these ancient things called LSTMs. Back then, we would create chatbots and things like that, but we'd never imagined that in less than 10 years, everyone is using them. These days, I co-led the PALM2 project, and now I'm working on Google SGE, the Search Generative Experience, and also Gemini.
Excellent. And Sudip, you are going to finish us off.
Hi. Hi, I'm Sudip. I'm the Director of Engineering at Cohere. Cohere is a foundation model provider, which is based out of Toronto. But we do have offices here as well as in London. Before Cohere, I used to work for Google as a researcher in Google Brain as well. Worked on ML pathways, which was then used for training large language models like PaLM. At Cohere, I lead a couple of teams. One of my teams is responsible for inference, so deploying our models in whatever environment we wish to deploy them in, as well as for fine-tuning, so customizing our language models for especially enterprise customers.
Excellent. So now you understand why I said they got to introduce themselves? Now, one thing that I want to start us off with, and this is a panel on enterprise and deployment, right? So enterprise, I think there is a very big factor that goes into using machine learning and AI with enterprises, and that is, what is the ROI and how much money does it cost? Everything around money we want to get very clear on. So Jonathan, I'm going to kick this off with you, and I know that you mentioned something around the brass tacks of how much these things actually cost and how we can look at cost. And so when it comes down to the costs, I know there are huge questions, whether that is how much it costs to actually train a model or fine-tune a model, or whether it is how much it costs for the resources that I need to actually be serving these models, or paying the engineers. So with all of that in mind, how can you have like a framework or something to go off of when it comes to looking at the costs?
I think it's actually pretty simple, at least for a lot of the folks you're seeing here. We've already built the models for the most part, or at least built the infrastructure to build the models, and that cost is baked in. So at the end of the day, everybody up here should be able to give you an exact number for how much it would cost to fine-tune and deploy their model. I can give you some exact numbers. If you were to take our model and you wanted to fine-tune it per billion tokens, you're talking about $700. That's not a lot. If you wanted to, one engineer month, let's say, call that, I don't know, $20,000 maybe, plus or minus. So if you're willing to invest one engineer month worth of investment in fine-tuning one of these models to customize it, cool, you're getting, tens of billions of tokens worth of training. That's really significant on your data. I'm curious actually to ask my peers here, how much would it cost to customize the Cohere Anthropic models? I don't know, genuinely.
Okay, so I'm not going to answer that exactly.
He's feeling feisty
tell you why,
after
though.
the acquisition.
Yes. I'll tell you why, though. For one, I think there are a lot of considerations that go into determining what the eventual cost is, right? For instance, what kind of fine-tuning you want to do, how much of the parameters of the model you want to update.
Let's say all the parameters.
But then what size of the model, what kind of hardware you need to run.
30 billion parameters, all the parameters of the model, what would the cost?
Right, so I don't know that off the top of my head because those are not our model sizes, right? So, but I think when we talk about ROIs, I think it's important to actually consider the return side of the equation as well, right? So let's say that you actually deploy a model in a healthcare setting, which enables a doctor to write up a referral really easily. So a task that used to take him 30 minutes now takes him 2 minutes because he doesn't need to draft that letter. He just needs to verify what the language model produced. Similarly, a lawyer who may be charging like $500 to $1,000 an hour can probably be much more efficient at his tasks. So it doesn't really matter if you spend like a few $1,000s or a few tens of thousands of dollars on like fine-tuning a model because that cost easily gets overcome by the much significantly larger returns that you can actually get in terms of human hours saved through these language models, for instance.
Excellent. All right, so...
But I still have to ask, is it a few tens of thousands of dollars then?
As I mentioned, I think, no, it should actually be a few $100s for some of our models.
Awesome, okay, that's brass tacks.
So, all right. Now, we've got a few more questions cruising along this cost idea. And Emmanuel, I'll kick it over to you because I know that Claude's got a gigantic context window. And one big question that I always think about is, when do you look at using that whole context window versus not using it? And why would you use it? And especially knowing that each token is going to cost you a little bit more.
I like that we got this far without me realizing. Okay. I train models. I don't do microphones. But anyways, what was I saying? Right, 100,000 tokens is the limit for Claude, which is roughly the length of like an average book. So when do you use that versus when you don't? I think there's like a question of like for many things that you do, you can rely on like, internal knowledge and just like ask the model to do a thing, and then you don't really need like a very large context window. But there's like a lot of tasks where you need to like pull in knowledge, and that's kind of like tasks where you've often seen things like LangChain be used, for example, right? Where like, you're like, okay, I have, let's say like I have all the Databricks docs, and I want people to be able to like answer questions about these docs. Instead of like retrieving these docs and like searching for them, which usually like kind of like takes some time and can be error prone, you could like put the whole docs in the context window and like ask a question about it. I think that generally like very long range chats is like another exciting thing for me personally, where it's like you could chat with like a chatbot for years and have it remember like everything you've ever said. And the other thing I think that we like called out in the demo, which like blew my mind, was like you could just paste like the financials of like a company that just announced their like quarterly results, and in like 5 seconds get a nice summary of like what happened. So anything that's like long document summarization, that sort of stuff is a good fit.
Awesome. And Ines, I feel like you also had something along these lines and the techniques and all that good stuff.
Yeah, it was essentially about how do we inject knowledge in these models. And for us, we work with structured data. You mentioned documentation of tables, etc. And how do we make the models aware, especially each organization has their own terminology for financial terms, insurance terms, and the public models don't have that. So these context windows with retrievers is one way to do it. So I like to call those inference time enrichment, because the model weights are not changed, but we can also do the fine-tuning piece as well. So when there's too much and we can't fit everything in the context, the models are really good at synthesizing information and summarizing that through the weights. So there's research on both ends, like one making longer and longer context windows and one on fine-tuning on domain-specific data. So, yeah.
Excellent. Andrew, I saw you bobbing your head. You got anything you want to add to that?
Yeah, I want to say that like long context windows do offer more applications. So especially in things like coding, you might want the model to know what's in your header files rather than just like guessing what's in there. That's usually useful. So it basically enables a wider range of applications, from like long book summarization to financial report summarization, as some of my other panelists have mentioned.
Okay, so this is enterprise and deployment. I want to do a little bit of the deployment part, and then we may get back to the enterprise. But I'll tie up this whole ROI and cost piece, because there is something that I just did this whole survey with a lot of people in the MLOps community, which I run, and a lot of people were talking about how when you're measuring ROI, despite what Jonathan says, it is still a little tricky to figure it out. And whether that is the time that an engineer is putting into having to deploy it, or the resources that you need, the GPU costs, all that stuff comes into play. And then you look at where are you taking that from? So is it like cost of goods? And how does that work? Somebody's phone's blowing up back there that I can tell. Yeah, take that call. So we are, when it comes to the ROI, it's like, where's it coming from? Yeah.
I think someone's looking for it.
Yeah, somebody's probably, they did find my iPhone.
Just to clarify your question, are you looking for the R or the I? Like, is this trying to calculate where the I comes from? Like, calculating how much it costs to actually deploy this, or is that what you're getting at?
No, I think what is just not clear still for people, besides you, is that the whole ROI is how many resources do I actually throw at this, and how can I figure out how much money I will make off of this tool or this feature. If I add AI to my product, can I charge more money because I have this AI? And if not, then I am still selling at the same price, but I am paying for the AI. Does that make sense?
Yeah, I think, I'm guessing we would all have the same answer to this, which is you start small and work your way up. The only way to really find out is to try. And very tiny investments and seeing what kind of return you get allow you to justify making bigger investments, running small experiments, A/B testing. It's honestly pretty similar to any other change that you'd make to a major product. You need to invest small, work your way up, see where you're getting signal, and continue improving from there. I'm curious if other folks have had a different experience.
Yeah, I was just gonna say, like, it's funny because I was just talking about this at a conference earlier that you were running, but like, so I used to run like an ML education program, and so yeah, like tips like these were ones that I would share often, and I think one of the things that like I drilled into people's brains, and I'm sorry for that, is like, just always start with like linear regression, or like get some like kind of like simple like pre-trained BERT or whatever. And I feel like one thing that I observed myself recently is that now you have these like very, very powerful general models And that's kind of like never really been the case before, in the sense that they've never been general enough that there would be a chance that they would work for your like very specific use case. But now, you can use like, Claude, like a Cohere model, like ChatGPT, some open source model, and just like kind of like get a very quick estimate of like how likely is this to work for your use case. Now, of course, like that model won't necessarily work as well as like something that you like train yourself or fine tune yourself. But I feel like that piece is something that I've made, a recommendation update on when I talk to like founder friends or like people that are at tech companies, is provided that there's no kind of like data privacy concern to do that immediately, like try one of the large models and like give it the instructions for the thing and see if like that works. And if that works, you have like a really good at least I estimate, right? You're like, well, this is how much it's going to cost me per call to do this thing. Is this worth it for me or not? And then you can discuss kind of taking the next step. But having that first step that takes 30 seconds is something that I had to update my prior on personally.
Sudip, you got something?
No, I pretty much agree with whatever else was said here. Yeah, I think the first step should always be just maybe use a SaaS API, right? You pay per call. It's easy to integrate, easy to experiment with. I think on the other side, again, on the return side, it really depends. It's not always as easy to measure the impact. Yes, you want to do A/B experiments and A/B testing as to evaluate it, but assigning a dollar value on the return is not necessarily always as easy, right? For certain use cases of language models, let's say for productivity increases use cases, right? If you're using Copilot, if a marketing person is using it to draft a copywriting email, then you may be able to measure it in employee hours saved, for instance. There are other use cases. For instance, if you're using it for content moderation of your gaming chat room, for instance, then it's harder to exactly quantify, right? There, I guess the quantifiable metric would be user happiness reports, whatever you are monitoring, whatever you're using to measure user satisfaction, and then you need to assign a dollar value to that. So it's not trivial, but yeah, there are ways and proxies for determining it. Sorry.
And I just want to say that for some things like customer-facing features, ROI might not be the right way to think about it. So overall, this technology might reduce your margins, but if you don't deploy it and put it in front of customers, other companies will. So it might, in the end, be a question of survival.
Awesome. And there are other times where just hitting an API doesn't work. And Ines, I know you are in that camp where you can't just hit some external API. Can you explain how you look at that and how you think about taking it one level deeper?
Yeah, and I agree with what Emmanuel said on the first step. I always advise as well to use APIs and prototype before actually building something. For us in the data space and data management, there's a lot of personalization that's needed to understand the domain-specific data. So finance, insurance, all these domains, it's really important to do that fine-tuning. As well as privacy is a big issue. A lot of the organizations are not okay sending their data to a third party. Even if sometimes the third-party company is not using the data for training, they're still not comfortable with that. So having a way to personalize the models for specific industries when they have very sensitive data is really important. Only in certain verticals, of course. Like if it's e-commerce, sometimes it's not as sensitive as healthcare, but that personalization and distillation of model is key.
Excellent. So I told you we were going to go with deployment, and then I went on a huge tangent there. So we're going back to deployment now. And Sudip, I'm going to ask you the different factors that you look at for choosing the right deployment strategy. And going back to that, that survey that we did, I know a lot of people talked about how the current infrastructure makes it very difficult to serve these gigantic models. And so how do you look at that when you are trying to deploy?
Right. So I think when I suggested that question, I guess it was not necessarily more from the point of view of how we deploy, but how a customer would choose different deployment options when they are considering potentially different providers and different deployment options that are available from different providers. So usually the initial first thing that anyone would try is a SaaS API, right? It's easy to use. And you would not even consider customization, right? The first product feature launch that uses an LLM would probably just use one of the SaaS API. You would potentially choose a product or a feature that doesn't have stringent privacy or security restrictions if your a product actually allows for that. After that, once you're happy, then I guess the next step is considering whether you actually have proprietary data that you can then leverage to improve the performance of the models. And there you need to consider different strategies, like whether you want to use a retrieval augmented generation model so that you can retrieve those relevant context from whatever external knowledge sources that you have, or you want to just bake in some of the knowledge within the model itself. And if you want to bake in some of the knowledge, then you then consider fine-tuning. So there's basically a spectrum of ease of use and using things out of the box to things that require significant investment and tuning to get the last bit of performance and cost savings at the other end of the spectrum. So yeah, but enterprises should consider what's the best fit.
I'm curious, and this is an innocent question for the folks who deploy big models. Is it more expensive if I were to customize your model to deploy it? Like, what do my deployment costs look like if I use the generic API versus if I wanted to customize the model and then use that? Does that change things?
I mean, I don't see a reason why it would. But I think maybe just to go back on the actual question, I think that wouldn't change really. One thing that I think would make a difference that I was thinking about is that I think using one of those APIs makes a lot more sense also if you don't have existing infrastructure in place. So one thing that before taking off my Anthropic hat, before I was at Anthropic, I was at Stripe, and at Stripe we had really good ML infrastructure, and so adding one more model, was just the cost of figuring out how to provision that machine, and we already had sane, feature storage, feature deployment, model provisioning, model monitoring, et cetera, yada, yada, yada. If a lot of companies, the LLM-based application is your first ML application, then I feel building that whole suite for it is a heavy lift. And so that's also one thing where you should consider in your deployment story, hey, can we reuse a bunch of things that we already have? And in which case, yeah, add another model to your suite of models and then judge them based on performance versus do I need to build this whole entire stack that there are entire fields studying the MLOps field anew.
All right. So I think that we can keep moving when it comes to this idea of open source versus closed. I get the feeling somebody on the panel is going to have a lot to say about this. And so, Jonathan, I want to kick this over to you and just think about how you look at whether or not it should be on, or how you think about open source versus closed, and then if you advise closed ever or open, and when and why.
I suggested this question because I think the open source versus closed source question is one I get a lot from customers. I think it's completely the wrong question, but I hear it a lot, and it's worth kind of addressing, and I'm curious to hear what other folks think. For me, it's really transparency and control versus lack of transparency and lack of control. There are open source models where we don't know what they were trained on, and you have about as much transparency into that model as you do into Claude or Cohere's models or GPT-4 or what have you. There are plenty of open source models where you do know everything about that model, and you probably don't want to touch it because you do know everything about that model, and that should make you very nervous. With the closed source models, you really legitimately have no idea. Then there's the spectrum of control versus lack of control. With an open source model, you do have an enormous amount of control over what you do with it. With a closed source model, you may have no control, you may have a limited degree of control. And so I think the real question for anyone, again, I love the open source versus closed source question because I think it's the wrong question, but people really mean transparency versus lack of transparency and control versus lack of control. And it depends on the application. If the model is good, oftentimes you don't care what's in it. If you're in a medical application, you may actually care that the model was trained on WebMD or what have you. That can matter quite a bit. And so to me, those are the two right questions. There's no right answer, But as an application designer, you probably have a good sense for whether you need control or not, or at least you can try and find out. And you probably have a good sense for whether you need to know what was in this model for very specific reasons, or whether you really don't care as long as it's good.
Sure. Yeah. I'm gonna say I think that was like a surprising, reasonable take. That's good.
Thank you.
I agree.
No, like seriously, because yeah, I think I agree with at least I agree that it's a bad question. I also agree that with like kind of the transparency take and control. I think if that matters to you, I think the other thing is this to me feels a lot. There's a lot of holy wars. This to me feels a lot like the if you're old enough, cloud versus your own data center. Holy war was a thing for years where people were like, well, you'd be a fool to run any business on top of a data center that you don't control. You need your own racks and your own machines. And in some cases, I think that's still true today, right? For some applications, you still need your own racks and your own machines. In many cases, you're yeah, as long as the machines run my code and I'm happy with it, that's good. I'm not saying that the kind of delimitation will be the same for models. I actually think it'll be quite different. But I think that there will be both for a while, and there'll be reasons to use either. The last thing I'll say, and I think it's obviously now putting my Anthropic hat back on, one thing that we care a lot about at Anthropic is safety. And so if you're generally concerned with kind of giving access to any model to anyone, and imagine maybe not today's model, but a much, much, much more powerful model, that's an argument for also in some cases saying okay, for some capabilities, we'll limit access to those. But then I think that there's many models that don't fall within that distinction, but I wanted to call it out.
Yeah, sorry. I pretty much agree with most of what was said, and that was actually a fairly reasonable take, right?
Why do you sound so surprised?
Because we heard the prior ones.
So I do believe that open source and closed source models will continue to exist in the future. Cohere itself has a Cohere for AI, which is a nonprofit research arm, which trains models based on community contributions. The data that is used to train these models is open source. The models themselves are open sourced as well. But we do want to also have a business, and we do want to solve specifically for problems that arise in large enterprises, whether it's on-prem deployment, whether it's actually developing a product that actually solves real use cases instead of just focusing on the model itself. So for all of those cases, for all of those reasons, closed proprietary models will continue to exist in the foreseeable future. But yeah, I'm all for open source models and a thriving open source community as well.
Yeah, I agree with what's been said before. And to add to Emmanuel's point, I do think the cloud versus your own server data center thing is one way to look at it, because right now these models are static, right? You train them once, they're fixed, and then they're deployed, which fits very well with an open source model. But that doesn't mean this will be the way in the future, right? You can imagine models might be continually improving or continually updated. And in those cases, probably the closed source models will be more up to date than the open source ones, which require a lot of investment to keep refreshing.
Yeah, and also aligned with everything that was said. I think there's also the aspect of size. The very, very big model can only be trained by big organizations like Anthropic, OpenAI, etc. So I think we're going to continue seeing the very good AGI models held by those organizations. But then there's also that wave of open source models that are much smaller. Recent research showing that 1 billion with very good data can get me very high quality. So I think we're going to see those two trends. At least that's my hypothesis, very big models solving AGI, general purpose, held by those very big organizations, and then a wave of open source that are going to be distributed and fine-tuned by each organizations individually.
Awesome. All right, so now we've come to the questions. So hopefully, after this thoughtful discussion, you all have some questions on your mind. Go ahead and raise your hand if you have any. Yeah, I see some in the back. I'm just going to ask you to stand up and shout your question at us because, oh, no, we have a microphone coming to you. All right, perfect. That's even better. Then you don't have to yell at us. That works. All right, so we've got the first question coming right up. Yeah, go ahead and grab that.
So I think my first question is more around what are the right approaches to kind of like fine tune your model, right? We heard a couple of approaches here. One is like, should we fine tune our model? Should we like, use techniques like RLHF? Should we prompt our models to kind of like make them more conditional to the context, right? Even there, I think there are questions whether we do retrieval augmented generation or we like enhance the context window to a point where everything can fit into the context window itself. So is there like a decision tree or is there like a way to think about it where enterprises can make these decisions more easily?
Yeah, so in my opinion, start with the simplest and the easiest, and then fine-tuning is probably actually at one extreme. And even before fine-tuning, I think one of the important steps that people usually gloss over is how do you actually collect the data that you want to fine-tune on, and how do you ensure that that is actually high-quality data. That bit is often challenging, like to basically get high-quality data that has been human-reviewed and get sufficient volume of it to actually be able to fine-tune a model is often more challenging than just running the fine-tune itself. So in order to avoid that, I think you can get a lot of performance with just retrieval augmented generations, right? Because that addresses a lot of the problems that usually happen with hallucinations, with data freshness, because you're retrieving the documents from an external memory, which is always guaranteed to be fresh. None of knowledge is baked into the model itself. So you need to take into consideration all of those factors instead of just going for fine-tuning, which may be very applicable in some situations.
I think another way to think about it is the size of your fine-tuning set. So if you were creating your own set in an afternoon, then maybe you have some like 10 examples, and that's good for a few shot learning. But if you have a bit more, maybe that's better for prompt tuning. And probably if you have like on the order of thousands, then you want to do something like fine-tuning.
Anybody else?
I mean, I think the answer to most of these questions of what do I do is cheapest to most expensive and easiest to hardest. This is all an empirical science, and we don't know the answers. Things inexplicably work or don't work, and it's really hard to predict in advance a lot of the time. So do what's cheapest and work your way up the ladder.
Maybe the last thing I'll say is like people are surprisingly bad at prompting, is what I found. So it's worth like reading. There's a lot of good open source docs on like, I think like, yeah, like whatever, OpenAI, the providers, Anthropic, maybe Cohere have one, but there's also like GitHub repos with like prompt tips, and it's like there's a lot of stuff you can do that, like you might think a model just does not do your task at all, and then once you apply like 10 to 12 tricks, it just does it. And so I think that's worth doing before you do a bunch of work.
Yeah, and there's also, piggybacking on that, there's also a lot of good open source frameworks out there that can help you, like something like Promptimize, and then you can test your prompts and see which ones work with what models. So we've got another question back there. Yeah, hit it.
Yeah, I'll be curious about what's your customers' take on privacy and maybe even the federated learning systems about that. So maybe you can speak about that.
I mean, I think those are two separate questions, really. When it comes to privacy, there are certain industries where you simply can't call out to an API. The model has to be within your control, and you need to know all the data that's going in and out. In a lot of those contexts, there's no substitute. The model has to be somewhere where you can control it and where you know the data is not going anywhere else or being stored. In those cases, there's nothing you can do. Federated learning, when it comes to, there are a lot of different approaches that have been proposed for trying to handle privacy in various cases. Federated learning is a whole separate example where you really need to separate into training and inference. Federated learning is a training technique where if you really need to combine a lot of different data, and perhaps you don't want to see what anybody else is providing data-wise, but you do want to be able to see updates to the model, we don't really have that strong of guarantees around things like federated learning. Even differential privacy, which hypothetically gives you a guarantee, it's really hard to concretize that and make it explicit. You have a certain amount of noise, but the threshold between did I add so much noise that I ruined my model versus did I add too little noise and the data can be extracted from the model, it's all an empirical science, and to me it's still a pretty dangerous game to play. You don't really know what you're getting. At the end of the day, your best guarantee is if you control the model, you train the model on whatever data you want, and nobody else can see that model except you, that is your only way to get a true guarantee right now.
Yeah, I was going to say, I feel like federated learning is like fine-tuning but worse right now in its value prop. It's like if you're thinking about it, you should probably just fine-tune. For what the first point you said, yeah, agreed. I think there's starting to be like some models that people like deploy within their like clouds. I think OpenAI announced something about like Azure and whatever. I imagine there'll be more of that where it's like you have some like model and it's like deployed in your cloud, or you have your own model.
Yeah, I think there's basically a spectrum of choices, right? So there's the SaaS API, which logs potentially some of your data. Some of the providers will let you opt out of data logging, but it's still a SaaS API. Then we have solutions like AWS SageMaker, which are hosted platforms. And for instance, like Cohere models are available there. And you can spin it up and still get benefits of a managed service. And it's completely private. No data leaves your environment. On top of that, there's like virtual private clouds, which is deploy our language models within your virtual private clouds. And on the extreme end, it's fully on-prem solutions, which are basically air-gapped environments. These are mostly like financial institutions or really highly sensitive enterprises who do not want any connection to the internet. And we have solutions in that space as well. So it really depends. And obviously, like the complexity of the deployment kind of increases as you go along from one end to the other end. But it really depends on which of these options is the right fit for you.
So, hang on, sorry. So, my friend invited me to here, so I don't really know what's going on. I barely use the internet, but what do you guys see, like AI or like the world in 10 years from now? Sorry.
I think that if you would have asked most of the people on this stage what they would have said 5 years ago about what the world would look like now, I looked at GPT-2 and I said, oh, that's cute. That's a very silly thing. Why did they train something so big? Then a couple years later, I looked at GPT-3 and said, oh, that's cute. Why did they train something so big? And here we are. Predicting the future is futile. And the only thing I can guarantee is you're going to be wrong and that the most extreme predictions are unlikely to be true. That's it.
Yeah, I said that the model after GPT-2 would be a huge waste of money, would never work. And I also said the iPad would never work. So like, don't ask me anything. So.
Meanwhile, how are all the crypto folks who predicted the future doing? So you never know.
It shows how quality this panel is.
You're not going to bait us on that question, I guess.
Did we have more questions? Yeah, I see one person here. Yeah, looking at you. Yeah, and Ines, I realized we did basically the in-person version of a mute button on a virtual panel. We took your microphone, so we'll let you have this one. Hopefully it is.
So frankly, I just follow up the federal learning question. So it seems like you sense it pretty down on the federal learning part, but there are many cases that you just cannot put the data together. For example, hospitals have different, if you want to train something with several hospitals, and their privacy data, the patient's data will not move. And if you're in the same company in the different Europe and American, China or Asia, the data cannot be moved out of the region. So with all these laws, privacy laws, so you have to use a federal learning to train these models. So it's kind of surprised to see that you're pretty.
The model is the data. The data is in the model. If you put the data together in a model, you have all that data in one place within the model, and that data can be extracted from the model. You cannot divorce the data from the model. And so if you do federated learning, you have brought all the data together. It's just in a different form.
Got it. Thank you.
Hi, thanks. I was curious what different approaches you have for evaluation frameworks, and if both quantitative and qualitative, and whether, how automated is that? Seems like a really interesting topic and probably an area where you need to develop a lot of tools.
I can speak for data transformation applications. So it's very much human in the loop in the prototyping phase. So user validate outputs, and we can monitor that interaction and understand how well the model is doing based on whether they clicked something or not. So it's very interaction-based, and in production, it boils down to classical ML of I have a ground truth set and I'm measuring quality on that ground truth set and making sure that the model performance is not degrading over time, etc. So more like classical ML solutions once the model is deployed.
Yeah, I think evaluation of large language models is like a fairly complex and hard problem, which I don't think has been solved yet. There's obviously a lot of academic benchmarks that you can use to measure the performance and do relative comparisons. Stanford runs the Helm benchmarks, which is, again, like basically a neutral evaluation of a bunch of large language models that are provided, that were evaluated, I guess, across 60 different task verticals and have multiple providers listed there. So you can get a relative evaluation of how each of these models is performing on each of these tasks. But what we have seen is that there are two things that we usually focus much or give much more importance to. One is specifically when we work with enterprises, we want the models to solve their specific tasks. So how our model actually performs for those specific enterprises. So we develop custom evaluation suites for each of them. And then the second is human evaluations. We have internal army of evaluators who evaluate our models for various aspects. And we have seen that that human evaluation is really the most indicative of how well the model is perceived.
True, but here's another thing I never thought I'd say, which is that now we're getting into the weird, bizarre world of you can actually ask your model to evaluate the model, and that sometimes works better than humans. Initially, when I saw these results, I also was like, oh, this is stupid. It will never work. But it turns out it makes sense, especially if like the task you're evaluating is something that would take a human, like let's say like longer than a quarter of a second. Like you'd have to like read something and be like, oh, well, is this actually like an effective summary or whatever? It turns out that like human raters are human and they get tired and they make mistakes when they rate like 100 things in a row. And so not for every case, but for many cases, you can like actually, you find that models, especially large language models, are better at grading than they are at generating. So the same model that like messed up half the time on the question you asked it can get like 95%, on like actually giving you the golden label on every question. And so in many cases, that's something that's worth trying and also makes no sense.
Yeah, so I would agree that that is I would say that's like a more extreme take on this. I think like if you have a model that grades itself and it says it's 100%, then that doesn't say a whole lot. But if it says it grades itself and it gets only 50%, that definitely says a lot, right? That means your model isn't great or isn't great at lying to itself. But
so I was just saying, you can use another model to grade your model. It doesn't have to be the same one.
Right. But that's also, there's another point there, which is like most of these models are trained on very similar data, right? They're all trained on web scrapes. And it's very likely that the deficiency in one model will show up in another model. So I'd caution against that. The other thing I would say is that be careful when you look at academic benchmarks. A lot of them right now are tainted. So there is like quite a significant degree of contamination in all of these. And I think like people should think about like doing things like rolling benchmarks or especially human evals are a bit more resistant to these kinds of things. But just take all the eval results you see with a grain of salt.
Yeah, I've seen the throat cutting gesture, which means I think it's time for us to wrap up. But I mean, I think there are really a couple lessons worth taking away. I think I've agreed with what everybody said. Number one is there are plenty of benchmarks out there. The academic benchmarks are sometimes vaguely indicative of when a model is garbage versus not garbage, but that's about it. Often these benchmarks are reasonable at like, this model is trash and this model is not, but aren't going to give you fine-grained distinctions between models that are various degrees of good. There are a bunch of interesting leaderboards out there and they're very interesting, but I don't know if they have much more information than that. But I think to maybe come back to the root of the question, if you were going to do any large language model related task or any really deep learning task today, evaluation is where it all starts. Until you have some measure of evaluation, you're not even doing machine learning. You may as well not bother. The thing that scares me most is if a customer came to me and spent $10 million training a model and then said afterward, so is it good? That is the nightmare scenario. When I wake up in a cold sweat, it's because I had a dream about that happening. But in all seriousness, the evaluation is where it begins. How would you evaluate a group of humans who are performing that task? If you don't have anything to go on there, you need to begin, to figure that out before you should even try to train a model or try to use it for anything.
That's it.